Hi, this is Philip. Finally, the refactoring is almost completed. Uh, Tons of changes, and not that many of those changes are visible from the outside. It looks mostly the same as it was before, but the truth is that most of the code inside the engine is changed. It is completely rewritten. Uh, what you can see from the outside is that now the model picking works for every possible model on the map. Okay, now we have just one car, but if we have multiple cars or whatever else, the model picking will be able to pick everything. I have changed the algorithm. It's not working anymore with the right casting method, but is using a second frame buffer and is picking the models from the back frame buffers, which colors and render every object in a specific color. So whenever you are moving with your mouse over the map or over the screen, uh, the engine is able to understand which color is beneath under the mouse cursor, and on the base of that color to pick the proper object. Um, I can show you how this looks like. The second buffer, the second frame buffer. I need to make a small hack in the code. I have to disable basically the switch between the two buffers. I have a default buffer for everything you see on the screen in a normal situation, and the back buffer for model picking. So now you're gonna see how this looks like. The back buffer? No, you don't. Wait a second. You forgot something? No, you don't. Of course not. Okay, so let's see. Now it's working. It shall work. Yeah, of course. This is the bug buffer. This is something which the user normally will not see, but what we see here is that every elements on the map has a different color. The car has a different color as well, and on the base of that color, when the mouse is moving over the map, the engine is able to understand what you are touching, which element are you touching. Now, actually, those are different colors. They are very similar, but there are slight changes, slight differences, which make it different. So cool. It's much faster than the old algorithm, which was very slow. It is much faster, and it's much easier to implement since before I had the terrain models and let's say and the car models, which had to be handled separately. Now everything is handled inside core renderer. Yes, okay. So big change is nice. Another important change is in the shaders. Where are the shaders? Before I had different shaders for different type of objects which I wanted to render. Now I have just one shader for everything. This is the vertex shader, but the fragment shader is a little bit more interesting. The vertex shader is, is very boring. Where is the fragment shader? Yes, it was refactored as well. Now we have this calculating flighting function, and before there was just one function for all. I mean, you can have a look into it if you want some specific differences. But the important part is that now the shader is loaded once when the core renderer starts, and then is not changed anymore. So even if we are driving text or whatever else, lines or whatever, the shader is always the same one, which is a big improvement in the performance. Since before I had a different renderer for the text rendering algorithm, sorry, algorithm, but mechanism. Now it's everything done by one shader, which is cool. Um, yeah, this is the frame buffer code. It's everything on my repo. I put everything on the master branch, so it's now merged. Big changes also on camera side. The changes are related with one improvement I made in the core renderer. Uh, Basically, this was a functionality which was present also in the old code, but was not very well implemented and was basically it was problematic to maintain from one side and was slow. Yeah, and I'm talking about frustum cooling. So basically, the idea is that you want to cool to cut everything which is out of the frustum. So basically, each model which is out of the frustum shall not be rendered. To do that, I'm using a geometrical approach. I have a frustum object, which is getting information from from the camera, of course from the camera, but also from the proportion, aspect ratio, and size of the frustum. Is creating is creating 6 planes. One plane, of course, for every possible side of the frustum. We have also the near and far plane, but which are most important for me at the moment are just the top, bottom, left, and right. And is checking whether a given point is inside or outside the frustum. If it's outside the frustum, then clearly the object should not be rendered. Uh, yes, it works in this way. That we have the frustum, we have the near plane, the far plane, and we have top, bottom, right, and left planes. And whatever is inside this frustum is going to be visible. Uh, whatever is outside is not going to be visible in frustum. Maybe there's some better image which is showing this. Is it showing the idea? Yeah, maybe it is. So everything inside is visible, outside is not visible. Yeah, but I'm using a geometric approach. There are other techniques, but this is fairly easy, and it works well. So basically, I have this frustum. The frustum is updated at the moment is updated at every frame, but the idea is that you're going to be updated only when the camera is moving. The first thing you do at each end render step is you update the frustum with the new information from the camera about the position of the front vector, upright vectors, and so on. The camera also is actually heavily refactored. Uh, the changes are mostly in performance and are in some glitches the old code had. Now, I mean, bug fix and stuff like that, which is actually and refactorings which make the code more readable. I think you mostly can have a look at the diff if you wish to see the difference. Big difference also in the way objects like units, stuff like that, are handled. Now is everything much more. The design is much better, let's say. So we have stuff like units container, which contain a certain amount of units. Then to place units on the map, you have the unit manager, which is a unit. So units contain unit, and unit is a renderable object. Um, big improvements also in the usability and the maintainability of the code. Now, the original code I started refactoring was because it was there was a lot of mess. Yeah, it was experimental code. Now everything is smooth, is much better, more, let's say, yeah, it's better. I mean, just have a look at the old code and not the new code. Um, it took me a ton of time to make this work. I can show you the diff. Uh, you can see this. I think this is the difference between the code today and the code that it was when I started refactoring. So tons of changes. But this was a needed step in order to make sure that this is going to be maintainable, extendable, and that I will be able to implement, this game in the future without having to deal with design problems, tons of design problems which now are fixed. Yes, as I said, it's mostly on the outside. The changes are mostly on the outside. I'm sorry, in the inside, of course. I was meant to say on the inside. But the changes are drastic, are dramatical. So yeah, it took me a lot of time. It was a lot of work, and I don't have that much time recently. But now I think I can start adding a new feature, uh, some new functionality, uh, which will make actually the game doing something. Ah, another small thing I can comment here is that I finally enabled face cooling, and I've fixed the blending mechanism, which was completely broken before, was not working. So cool. Yeah, that's all. Have a look at my repo for all the changes if you want. Where's my repo? Here's my repo. OpenGL Play. I need to change the name. The change is not nice. The name is not nice, but that's all. And see you soon.